Hello, this is Satbe. The topic of our discussion in this video tutorial is the fourth counting principle, which is the division rule. What is the division rule of counting? Suppose there is a procedure that can be carried out in n ways. The total number of ways to carry that procedure is n, but there are some repetition in these n ways. And if you pick a way w, and there are d number of repetition which is corresponding to that way w, then in order to remove these repetition we use the division rule, which states that the total number of ways to complete the procedure is n, which is the total number of way, divided by the repetition of the way w, which has exactly d of them. Now let's take a few examples and try to have some better understanding of the division rule. So our first example is how many ways we can arrange two red tile and one yellow tile. So the problem say that we have two red tile and one yellow tile. And we want to find all the different arrangement of these three tiles. So you may think that we can use the permutation to find all the arrangement of these three tiles, because this is a problem of arrangement, so we can use the permutation to solve it. So by the method of permutation, we have three tile and there are three position to place. So this is the three tile into three position will be given by 3 factorial, which also can be written as 3 times 2 times 1, which is equal to 6. So there will be a 6 arrangement of these three tiles. So the sixth way we can arrange these three tiles. So let me first write down all the 6 way, and then we will see that there will be some repetition, and we will find a way to basically remove these repetition by using the division rule. So if we use the method of permutation, these will be the 6 way to arrange these tile. But as you can see that there are some way which are repeated. For example, these two are identical way, and these two and these two. The reason is this, because when we use the method of permutation assume that each object is distinct. So for example, in this case, the method of permutation will mark this tile as a tile number 1 and this is a tile number 2, and then the yellow tile. So the method of permutation is going to consider this problem as a 3 distinct tile, and then is going to find all the arrangement or all the shuffling, you can say. So the second arrangement, the permutation will do that. I will basically, the tile which is on the second position, it will basically move to the first position. The tile which is on the first position move to the second position, and so on. This will be a first tile, second tile, second tile, first tile. But in our problems, we don't need the repetition, because for us, the red, red, yellow and red, red, yellow is basically a one way. So basically identical way, we have to remove these repetition. So what we can do, we can remove these repetition by using the division rule. So now let's talk about how we use the division rule. So the first thing is, first we will compute the total number of ways, and then we have to group them. So in that grouping, the one way basically is collect all the repetition which is corresponding to that way. So for example, in this grouping, there are two repetition when red, red, yellow. So if we even permute the two red tile, that will give us a repetition. And in the second, basically when I have red first, yellow middle, and then the red, then all the basically the rapid, all the way which corresponding to that we will group into here. And Those tile which has yellow first and red, these will into be a three group. So basically, in order to use the division rule, first we have to group the total number of way, and in each group you must have same number of repetition. So as you can see, the total number of repetition in the first group is 2, in the second group is also 2, and the third group is also 2. And then basically, in order to find the total number of way, therefore the total uh, arrangement is given by the division rule, which will be a 6 divided by 2. This gives us 3, because this will discard this repetition and this repetition. So we use the division rule if the whole procedure can be divided into certain number of groups, and each group must have same number of element or same number of repetition which corresponding to that group. So this is really important for a division rule, that the each way is repeated, each way has the repetition, and it have exactly the same number of repetition which is corresponding to that particular way. Then we can use the division rule. Now the question is that why I use the division rule instead of the subtraction rule, because I could have used the subtraction rule, because I know there are three ways which are basically corresponding the identical to the way which are already present. So therefore I could have done 6 minus 3, which is equal to also 3. So this is by using the subtraction rule. So yes, the answer to that question is correct, because you can always use the subtraction rule instead of the division rule. But in some problem, it become very complicated, because we have to write all the ways. We have to list all the ways, and then we have to find the all the repetitions in that way. So using a subtraction rule is a bit more complex and more hard. But the division rule do synthesize the problem and to make it easier to solve. So this is the reason we use the division rule instead of the subtraction rule, because subtraction rule are used in a very particular example where it is easier to find the repetitions. But if there are too many repetitions and you have to find all of them, I would prefer to use the division rule instead of the subtraction rule. Now I will give you also one more example, that there are some problem where you cannot use the division rule, you can only use the subtraction rule, because the division rule is used in a very particular situation. However, the subtraction rule can be used in a very more general setting. So let me give you an example. I'm gonna take the same example which I showed you when in the video of the subtraction rule. The example was, we have to pick one card out of a standard deck of 52 cards, and either you can pick a king or a heart card. So there are 4 king and 13 heart. So the total number of way to select one card, so that the conjunction is or here, is gonna be a 4 plus 13, which is equal to 17. So that is the total number of way to pick one card out of basically 4 king and 13's heart. But then we notice in that problem there was a repetition. There was a one repetition, which is a king can be a heart. So that is a repetition. A king card, a king plus heart can be occur at the same time. So we have to delete that. Basically, we have to subtract this repetition in order to find the total number of way, which is in this case is a 16. So we use the subtraction rule in order to kill the doubling. You know. So now we compare this example with the example we have in this question. So as you can see, the subtraction rule, in the subtraction rule, there was only a one way which has a repetition. But in the division rule, every way has some repetition. So in nutshell, I would say the division rule is used when every way has a repetition and they have exactly same number of repetition if you divide into groups. However, in the subtraction rule, there are some way which has a repetition, but not all. Because if all way has a repetition, then we will use the division rule. But if some way has a repetition, then we will use the subtraction rule. And also in the division rule, if all the group have same number of repetition, then we use the division rule. But if, for example, if you have 2 and there are like 3 way to corresponding to this, then we won't be able to use the division rule. So for the using a division rule is really important, that the total number of ways can be divided into a certain number of groups, and each group must have exactly same number of repetition or same way to basically have that one way written. However, in the subtraction rule, there are some way which has a doubling or repetition, so we just have to go through and find out that and then subtract it. So this is the major difference between the subtraction rule and the division rule. And it is a really important concept to understand that what is the difference, because sometimes it is confusing that when to use the division rule, when to use the subtraction rule. Now let's take few more example and try to understand this division rule in more depth. Our next example is how many way to divide 12 student into 3 group of 4. So there are some counting problem. If you basically find a sample problem which is easier to think or easier to draw, we will solve that first to get more understanding of the problem, and then we will solve the general problem in the question. So I'm gonna create a sample problem out of this bit more harder problem, and this sample problem will be easier than what we have in the question. So what I'm going to do is, instead of 12 student, I'm going to take 4 student and I'm going to take 2 group. So each group will contain 2 student. So now I can basically draw this problem. I can say that I have a student S1, S2, S3 and S4. And if I have to divide into groups, I can say like, okay, this is my first group, this is the second group. Or I can do is basically I can find S2, S1, S3, S4. I would say this is my first group or this is my second group. So now you can think that this problem is actually a permutation problem. So we can think is that a permutation problem to find the total ways. And when we permute, then each time we permute, then the first 2 member of that permutation or that way is our first group, and the last 2 is the second group. So this is how we can also group these students into 2 way. So first is, what is the total number of way? It means 4 student has to place into 4 position. That is a 4 factorial, which is a 4 time 3 time 2 time 1. Now there are some repetition. If I do basically this, which is going to be 24, that 24 way to basically put the student into line. So S1, S2, S3, S4, or S2, S1, S3, S4. So there will be a 24, but there are some repetition. As you can see that if I permute S1 with S2, which I did it here, or I just not permute S3 with S4, this is a same permutation for us, because the order really doesn't matter in the group. So if I have S1 S2 or S2 S1, it's the same student. Since the order does not matter, there are going to be some repetition which we have to remove, and this time we will see that we will use the division rule. So now first take this permutation S1, S2, S3, S4. So now if I permute the first one S2 with S1, and then this will be S3, S4. That will be a same basically permutation. Or I can do is I take S1, S2 and I permute the second one as 4, S3. That is another way. Or I can take the second one S2, S1 and then I also can permute S4 with S3. That is as the same permutation. Or I can basically first permute the group S3, S4 and S1 and S2, and then I can find another permutation, basically S4, S3, which is S1, S2, S4, S3, S2, S1, and the last one is S3, S4, S1, S2. So you see that if I take one permutation, there are 8 other permutation which is corresponding to that permutation. You know. And if I take another group, for example, so this is my one group which has 8 permutation. If I take another group of permutation, means S1 now with S4 and S2 with S3, and I calculate all the permutation which corresponding to this, and that will be also 8. You know? So it means then I can take another one which will have also the 8. So it means basically each group of permutation, this whole permutation can be divided into 3 groups actually, and each group will have exactly 8 number of repetition. So by division rule it will be 24 divided by 8, which is equal to 3. So there is only a 3 distinct way we can create a group of 4 students, 2 group of 4 students, so that the each group will have 2 students. So now also let's understand that how we can able to find that 8 permutation without writing it down. So basically let me explain you to more mathematical way to find all of them. So you see we have the permutation S1, S2, and then you have S3, S4. So that was the one group. So these are the 2 elements in that group. So in order to permute them, there are the 2 factorial. Because each permutation of the first group will give us the same way. So therefore that is the 2 factorial. And this one also has the 2 element that is basically also 2 factorial, because the total number of way you can arrange S3 and S4 is also 2. And also you can see the conjunction is and, because we get when we permute S1 and S2 and then S3 and S4. So there is a conjunction and. So the total number of way to permute is 2 factorial and also 2 factorial. That is the total number of way to permute S1, S2 and S3 and S4. But also this is sort of a group 1 and group 2, and if I permute these group, I get the same number of repetition again. So basically, or the identical repetition. So therefore this is also the 2 factorial. So this whole group G1 and G2, because they're 2 elements, they can also be permuted with a permutation which is a 2 factorial. So as you can see that this is a conjunction is also and, because I have to permute S1, S2, S3, S4 and also the group. So all the permutation which you can find here, which I list 8 of them. So therefore actually the solution of this problem should be the factorial 24, 2 factorial, which is the permutation of the first group, the 2 factorial, which is the permutation of the second group, and how many number of group we have, which is the permutation of that group. So now we can solve our actual example, that is the solution of example number 2. So what will be the solution? So as you can see, there are total 12 students. So there are 12 factorial way to permute them or to arrange them into a 12 positions. And we have 3 group, but each group have 4 student. So in the first group we're gonna have 4 student, we can permute in 4 way. In the second group, we're gonna have another 4 student, which we gonna be promoted in 4 way, and then the third group, which is also have 4 student, which has 4 permutation. And then we will multiply also the number of group, because then if we permute the group, that will also give me the same permutation. So this will be the total number of permutation to basically total number of ways to divide 12 student into 3 group of 4. So if you calculate this number by using your calculator or computer, you will get 5775. So that is the total number of ways you can divide 12 student into 3 group of 4. So also we can write the general formula for this problem. So for example, if you have n students, you have to divide this into m group, and then the total number of student, which we gonna call, let's suppose r, which will be n divided by m, because the total number of student divided by the total number of group. Then the how many ways you can define. So therefore the total numbers of ways will be n factorial, and then you have to divide into m group, and each group will consist r number of student. Therefore this is going to be r factorial, so on up to r factorial, and then the m factorial. So this will be our general formula to calculate the n number of student if you have to divide into m groups, and each group will contain r number of students. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. For example number 3 is, we have 6 colored brick in total. 4 of them are red and 2 of them are white. In how many way we can arrange them? So let's first visualize this problem. So we have total 6 bricks and 4 of them are red. So the 4 bricks are red and the 2 of them are white. So 2 bricks are white, and we need to find how many ways we can arrange them. So the total number of arrangement. So as you can see, these problems look really similar to the product or the permutation problem, but the only problem is there are identical object. So it means there are some repetition which we have to remove. So according to the formula, the total number of arrangement of these 6 object will be 6 factorial. And now we basically use the division rule to cancel or discredit all the repetition. So as you can see, these are the 4 identical objects. So there's by 4 factorial way, these permutation will belong to the same permutation, or it belong to the same ways. And in the second group, you have 2 objects, so this will be a 2 factorial way to permute them, and that will also belong to the same way. But this time, if I switch these group, this one with that one, I will have a different permutation, so that will, I don't have to discredit. So this problem is a little bit different than the previous examples we discussed. In this time, when you switch the group, the order matter, because the white then all red, it going to be a different permutation, so we will not divide of switching the group. So this will be the total number of way to arrange these 6 brick. 4 of them are red and 2 of them are white. So now we can calculate. So if you simplify, you will get the total 15. So it means there are 15 different arrangement for this example. Our example number 4 is, how many different ways are there to seat 4 people around a circular table? where two seating are considered the same when each person has the same left neighbor and the same right neighbor. So our problem is we have a circular table. Is this circular table has 4 seats and we need to seat 4 people around this table. One way I can do is I can put one person here, 2 here, 3 here, and 4 here. So this is the one arrangement. So as you can see that this problems look like a permutation problem because you have 4 people and then you need to seat 4 people on 4 seat, which will be 4 factorial, which you can calculate 4 times 3 times 2 times 1, and if I calculate this it will give 24. So there are 24 different way to seat 4 people around a table. But in the problem it says that if I seat these 4 people, there are some arrangement which we need to discard. For example, if I pick one arrangement this and this arrangement corresponding to this this way. So if I seat 1 here, 2 here, 3 here and 4 here. This is the same arrangement because on the left and right of 1 we have the same person, the same peoples, basically 2 and the person number 2 and the person number 4. So we have to discredit that one. So it's not just the 2, there are more actually arrangement which we need to discard. For example, if I put 1 here, 2 here, 3 here and 4, this is the arrangement which we need to discredit because this arrangement is also corresponding to when the person number 2 and 4 sitting on the left and right of 1. And there is one more actually, as you can see. If I make 1 here, 2 here, 3 here and 4. So you see that there are the 4 actually arrangement which are corresponding to this arrangement, the one I choose, 1, 2, 3 and 4. So this is sort of problem can be divided into a group where each group will consist the 4 same arrangement. What that I mean is actually if I pick another arrangement which does not belong to this group, and for example I put 1 here and 3 here, 4 here and 2 here. So this is a different arrangement which do not belong to this group, and I can compute all the other arrangement which are corresponding to this arrangement by just rotating it. So as you can see that if I rotate these arrangement 3 more times, so I have 4 arrangement which will corresponding to this group. So then I can find another group which does not belong to this group, and I can compute the number of arrangement in that group. Or in other way, I can say that each group, so if I pick randomly 1 ways, there are 3 other, means there are total 4 repetition in that group. So one group has 4 repetitions, so I will need to divide by 4 the total number of ways. So in this case, the total number of permutations will be 8. So this will be the total number of distinct way, which is 8. Here I have one more quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. This is also the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.